Understanding Interest Rates. This is Chapter 5, Part 4. Following are the learning outcomes. After going through this presentation, students will be able to compare and contrast different compounding periods, analyze the significance of annual percentage rate and effective annual rate, and sometimes APY. We'll probably talk about it in the next presentation as quotes in the real world. But yeah, we'll understand the significance right now. Later on, we'll be able to compare and contrast these APRs and APYs to understand how banks quote interest rates and analyze mortgage payments and payments related to investments that are related to interest rates, analyze the growth of retirement funds that grow with time and related to the rate of return. So now let's understand what's compounding period. So far what we've seen is the rate of interest was matching with the number of years. However, in real world that's not true. In the real world, sometimes we have monthly compounding, sometimes we have semi-annual compounding. In fact, most of the credit card compounds per day. So we need to understand, are there any useful features of this, or are there any drawbacks of this? Who emerges as a winner at the end of all this compounding? So in this table we look at the measure as in how many, what is the measure as in months, half years, or days. The compounding period is 6 months, and the number of compounding periods per year is defined as NPER, number of periods per year. So NPER PY. And so if 6 compounding periods per year, then there'll be 2 such compounding periods. If 6 months per year, the rate is compounded every 6 months, then there are 2 compounding periods per year in a 12-month product, in a 12-month period. And then the product of these two has to be 12 months. If it's 4 months, then there will be 3 NPER PY to get the product as 12 months again, 1 year. That should be the product. And then if it's the compounding period is 3 months, then that's a quarter. So every quarter the rate is compounded. So 4 such quarters in a year, and the product is this 12. Then if it's compounded per month, that is 1 month, then there should be 12 such compounding periods, and therefore the product of compounding periods and NPER PY is 1 times 12, or 12. So notice how the product always comes out to 1 year. And if the compounding happens per day, then the compounding period is 1 day, and there are 365 such days in a year, and therefore the product of these two becomes again 1 year. Okay, now how are these, once we understand what is a compounding period, how do we compute interest rates per year based on the compounding rate, or the periodic rate? So the periodic rate is a rate applicable to that period in which compounding takes place, such as 1 day, or 3 months, or 4 months, or 1 year. And so that's called periodic rate. Periodic rate is not annual equivalent. To get the annual equivalent of that periodic rate, then we multiply it by the number of periods per year. For example, if the half-year rate is 2%, then the annual rate becomes 4%, because we multiplied it by 2, or 2 half years in a year. Similarly, if the quarterly rate is 1%, then the annual rate would become 1 times 4, or 4%. So in other words, we can say the annual rate divided by the number of periods per year is the periodic rate. So again, equivalent is a very loose word for it. It's annual periodic rate. Annual periodic rate. 1 plus periodic rate to the power of number of periods per year minus 1 is the effective annual rate. So what's happening here is you take the periodic rate, add 1 to it, and compound it for the number of periods in a year, and then take that 1 that you invested in away from it. So you'll just be left with what is the effective rate at which your money has grown. Now how do you calculate the periodic rate from annual rate, or APR, annual percentage rate? So again, when the measure is in months and the compounding period is half a year, and then the number of periods per year is 2, if the rate is 12%, then the periodic rate is 12 divided by 2, or 6. So 12 divided by 2 is 6. If the measure is monthly and the compounding period is 4 months, then there are 3 such 4 months in a year. If the APR is 12, given that there are 3 such periods per year, the periodic rate will be 4%. Next, if the measure is still months and the compounding period is 3 months, so it's a quarter, there are 4 such quarters in a year, and therefore rate is 12% divided by 4 quarters will give us 3%. Next, if the measure is still monthly, but now our compounding period is only 1 month per period, and then therefore we'll have 12 months in the compounding period, or 12 compounding periods in a year. If the rate is 12% divided by 12 compounding periods, so periodic rate or monthly rate is going to be 1%. Last but not the least, if the measure is daily, the compounding period is 1 day, the number of periods per year is 365, and if the rate is 3.65%, then we divide 3.65 by 365 to get 0.01%. That's how we calculate the periodic rate. Now this is not annual. Periodic rate is applicable only to the period. So let's move on. Now here we have a table. In the table we want to show how much does $1,000, the beginning balance, become in 1 year. So if the rate of interest, as we saw in the previous slide, is 12%, but with annual compounding, so it's multiplied by 12 to get an interest of 120. 120 is then added to the beginning balance to get 1120. With semi-annual compounding, now you have to break the periods up into 2 parts. So each half will accrue an interest of 12% divided by 2, because remember 12% was APR. So it's going to be 6% of 1,000 or $60. That'll be giving us the ending balance at the end of first 6 months. Then we take the ending balance of 1060 and apply the semi-annual rate again on that. So 12% divided by 2 times 1060 gives us 63.6. Add the 63.6 to 1060 to get 1123.6. Now let's move on to quarterly compounding. Balance is still 1000 at the beginning. When we multiply with not 12% but the quarterly equivalent, so 12% divided by 4 quarters in a year, so 3%. 3% of 1000 is $30. That $30 is added to the initial balance to get an ending balance of 1030. So this investor did not want to withdraw the money, instead just let it keep growing. Now you have this 1030, again multiply it with the periodic rate, 12 by 4% or 3% times 1030 gives us 30.9. So 30.9 is then added to 1030 to get 1060.9. Next step. Now remember it's quarterly compounding, so we've only accomplished half a year. We have to go full year. Same thing, we have this 1060.9 multiplied with the rate by 4, that is a quarterly rate, to get the interest. Add that interest to the beginning balance to get the final ending balance of 1092.6. Lastly, again repeat this step for the 4th time. So beginning balance is now 1092.7 times 3% gives us $32. $30 plus 1092.7 will give us 1125.51. Now in other words, if we compare the 3 results, with annual compounding we got 1120, with semi-annual the value increased to 1123.6, and with quarterly it increased even further to 1125.5. So this is the concept of effective annual rate. Even though the rate of interest was 12% per annum, with quarterly compounding we seem to be coming out the biggest winner among all these 3 categories. So the effective annual rate is the rate of interest that is effectively earned. It has to be not quoted as APR. Now with annual compounding, the rate of interest of 12%, semi-annual becomes 12.36%. With semi-annual compounding, we do the same thing, 1 plus rate to the power of time minus 1. Or in fact in Excel there's a function called the effect function. So let's quickly go to Excel to see that. So let's see, we have 12%, and this is 6 months. So there are 2 half years per year. So the periodic rate is going to be 12% divided by 2, or 6%. That is a periodic rate. Now we annualize it, so equals parenthesis 1 plus 6% to the power 2 minus 1. So it's traveled the 2 periods and then we take it back. So this is 12.36%. That is the effective annual rate. But wait, we can do this in another way. So it's the function called EFFECT, effect, nominal APR, annual, and number of periods per year. So there are 2 6 months per year. And that's it. It's given us the same answer. This answer, this answer is the same as this answer. So 12.36% of 1000 is 123.6. So the value amounts to 1123.6 as we just saw. And then it is also given as 1 plus periodic rate to the power of number of periods minus 1 in percent. So to see that, equals parenthesis 1 plus periodic rate to the power of number of periods minus 1. Nope, that didn't work. Divided by 2. There you go, that worked. So that's how we calculate the effective rate. Effective rate is usually bigger, and we just showed that Excel example a minute ago. With quarterly, it's 12.55%. So to see that, all we have to do is divide it by 4 and to the power of 4, 12.55%, and so on. So the observation is that more the compounding periods, the greater the effective annual rate and greater the future value. So here is the illustration. So as we see, when it's 2 periods, the effective rate is 12.36. That is semi-annual compounding. If it's 3 months, then the rate becomes 12.49. If the rate number of periods is 4 periods per year, then the effective annual rate is 12.55, as we just saw. Then with annual compounding, 12%, with monthly compounding, I beg your pardon, 12% becomes 12.68%. So to see that, let's see that. So all we have to divide it by 12 and to the power of 12, 12.68%. That's how we get it. And then with daily compounding, that's the most interesting. So we divide it by 365 and to the power of 365, 12.75%, which is exactly what we got here. So all in all, the summary is this: as the number of periods per year increase, the effective annual rate also increases. Now we connect APR with EAR and EAR with real life. So suppose we're interested in taking a car loan. We want to buy a Tesla Model 3 with a value of $48,000. So we approach a bank for a loan. The deals are either pay $45,000 in cash. Actually, the deals that are available with the dealership is $45,000 cash. But the bank actually says you can pay $3,000 down and $775 per month for 72 months, $3,500 down, $877 per month for 60 months, $4,000 down, and $2,615 per quarter for 20 quarters or 5 years, and then 0 down and $7,035 per half a year for 8 half years or 4 years. So I've already copy pasted these values in Excel for you, and so we can just quickly find out the periodic rate. So equals rate, number of periods, the payment is negative $775, the present value is 48,000 minus the down payment, the value of loan we need, future value is 0, type is 0, and guess is 0.07. Enter. This is the periodic rate, and just do Control D, Control D, Control D. Next is the APR. So this times 12. Control D, Control D, Control D. There is some problem for sure. So F3 times 12, good. Sorry. This has to be times number of periods per year. There you go. All good. Finally, the effective annual rate. So we'll use the effect function this time. Effect APR, comma, the number of payments per year that you make. 7.6, 7.02, 7.0, and 7.49. So these are all 7 something rates, and let's compare them now. So here's a comparison. So all the results I've carried forward here onto the slide. And now first let's look at this. Between the second option and third option, the option 3 has a higher APR, but it has a lower effective annual rate. What it means is that the total amount of payment that we could end up making in interest for the quarterly option, given that rate, is actually lower than the monthly option for 60 months. In other words, we choose this project with this particular payment stream for the loan. Now here we have another interesting case. This is between first and fourth. So the first case, if you remember, monthly compounding, 6 years, and the payment is 775 with 2 periods per year and 8 half years. We have 7035 as the semi-annual payment. So that affects us and gives tantamounts to APR of same value for both these loans, but effective rate for the semi-annual is actually lower than that for monthly. And the payments that we see, the reason for that is pretty curious. So payment for the first option is 775, the second option is 7035 because we're paying every 6 months. So this amounts to 9,300 a year. We have no basis to compare, but this is just, ballpark, and we're paying more in the second loan, and yet we choose the second loan because its effective annual rate is lower. And the reason for all that is just because we make a larger payment, we're also able to pay down the principal faster. So to conclude, effective annual rates are based on a per period valuation. Effective rates are very important to determine the actual interest cost burden on the borrower, and the principal needs to be repaid. That's a very important thing. APRs are just good enough to assess the annual rate by a rule of thumb. So they're not actually effective rates. They don't mean anything in that respect. It is a standard to use APR though as an interest rate because they're kind of close to each other. An effective annual rate is a rate that provides the actual information of the cost of a loan. How much are we really bearing in terms of the cost of that loan? Periodic interest rate is the APR divided by number of periods per year, and it's used to calculate compound interest as well as EAR, the effective annual rate. That's chapter 5, part 4. Thank you for listening.